चलिए डन गाइस, yes or no, please tell me.
No, sir.
अच्छा चलिए. Vapor pressure of chloroform and dichloromethane are given as 200 mm of Hg and 415 mm of Hg respectively. Calculate the vapor pressure of the solution prepared by mixing 25.5 gram of CHCl3 and 40 gram of CH2Cl2. Done guys, yes or no?
Yes. Yes, sir.
Okay, fine. First of all, let me tell you that this has been asked many times. बट आप बताइए अच्छा सवाल है या नहीं सवाल है. लेट मी टेल यू व्हाट इज द सिचुएशन, है ना. व्हाट इज द सिचुएशन, आई विल टेल यू गाइस. ठीक है. सो प्लीज ऑल ऑफ यू, अब्दुल रहमान, मैमूना, सैफ, रिदांश, राबिया, experimental point of view से, realistic point of view से, you will tell me whether it is a good question or a bad question. So what they have given, first question is calculate the vapor pressure of solution prepared by mixing. So they're saying I am mixing, so we know the values, है ना. So they are saying they are mixing only, ना, they are mixing. What are they mixing? In this type of container. Okay, black नहीं हुआ. ब्लैक क्यों नहीं हुआ भाई? तुम ब्लैक हो गया. So also then we have chloroform. Let us say blue color में हमने chloroform दिखा दिया. And we have also mixed CH2Cl2, right? So just show this in red color. मिला दिया हम. अब इनके कुछ वेपर्स होंगे. They will be having some vapors in the solution, है ना. Just above the solution there will be some vapors. There will be some blue one and there will be some red ones. Okay. And now what they are asking, calculate the vapor pressure of solution. Calculate the vapor pressure of solution. ठीक है ना. What they are asking, they are asking that whatever the vapor is present due to CHCl3 and CH2Cl2 in the solution, what is its pressure? अब बताइए, is this a good question to ask? That means they're asking you to calculate something, ना? Yes or no? They're asking you to calculate the pressure. Correct है?
Yes.
है ना. So we have to calculate the value of pressure, but we know that in order to get the value of anything, we have two methods. We can either measure it or we can calculate it. तो आपको measure करने तो कभी नहीं बोला जाएगा सवाल में, यानी कि आपको क्या करने कहा जा रहा है, कैलकुलेट करने कहा जा रहा है. बट इज दिस अ गुड वे? कैन वी नॉट मेजर द प्रेशर? यहाँ पे अगर हम मैनोमीटर लगा दें या बैरोमीटर लगा दें, इट विल गिव मी द प्रेशर ना. यस और नो?
Yes, sir.
इज देयर एनी नीड टू कैलकुलेट? इज देयर एनी नीड टू कैलकुलेट?
No.
No.
है ना. ठीक है. इज दिस अ गुड क्वेश्चन और अ बैड क्वेश्चन? Is this a good question or a bad question?
Like it's easy, so we are gaining marks. So
Yeah, it is important question. I will say, I'm not saying it is not important. It is important question, but it is a bad question. ठीक है. Second question is good. Second question I will say that. Second question ये देखिए. अच्छा, ये second question में थोड़ा सा mistake है, sorry, है ना. बेवकूफी वाली बात लिख दी है यहाँ पे, sorry. Mole fraction of each component in vapor phase. है ना. ये अच्छा सवाल हो गया. वेपर फेज को यहाँ पे कितने मोल्स हैं हर एक गैस के. अब ये सोचिए ना, इसको तो हम मेजर कभी कर ही नहीं सकते, राइट. वी कैन ओनली कैलकुलेट दिस, व्हाट इज द मोल फ्रैक्शन ऑफ ईच कंपोनेंट इन द वेपर फेज. सो द सेकंड वन इज राइट बिकॉज वी कैन नॉट मेजर इट. थिंक अबाउट इट. अगर ऐसा रहता, थिंक अबाउट इट ना, देन इट मींस दैट यू कैन कैलकुलेट व्हाट इज द नंबर ऑफ पार्टिकल्स और नंबर ऑफ मोल्स इन. कहीं पे भी अगर आपको गैस मिला, आप वहां पे जाके एक मेजरमेंट के लिए कुछ टूल है उसको ले जा रहे हैं, वो बता दे रहा है आपको. सो यू डोंट हैव एनी measuring tool अगर होगा भी, that will be very 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 expensive, है ना. That will be very expensive. So this is a good question. The first one is a bad question. ठीक है, or bad question, but it is important. तो करना तो पड़ेगा. So we'll do it. So in that we have one information, 25.05 of CHCl3, 40 gram of CH2Cl2 at 290 Kelvin. Let's see how we are going to solve this. What do we need? We need P total. So also we know that P total is equal to the partial pressure which will be due to A and the partial pressure which will be due to B. अब यहीं पे हम लोग देख लेते हैं PA क्या ले लेते हैं, PA को ले लेते हैं पहले जो भी दिया हुआ CHCl3 दिया हुआ, ठीक है ना. P is CHCl3. What is PB? Let us take CH2Cl2, है ना. Now this will be equal to the P naught of CHCl3 into the mole fraction of CHCl3 plus the P naught of CH2Cl2 into the mole fraction of CH2Cl2, and we will get the P total. We will get the P total. So in this case, they have given us the pure vapor pressure of CHCl3, pure vapor pressure of CH2Cl2. They have given you this information from which you can calculate the number of moles, and hence you can also calculate the mole fraction. तो जो information important है उसको लिख लेते हैं, then we will start calculating. ठीक है. First of all, I will decrease the size of this. अब लिखने की जरूरत नहीं है. ठीक है. So we have, now please listen very carefully, 25.5 grams of CHCl3 and what we are mixing, 40 grams of CH2Cl2. ठीक है. So from this we are going to get the number of moles of A, and from here we are going to get the number of moles of B. है ना. A B क्या ही लिखते हैं, A B नहीं लिखते हैं, ऐसे लिख देते हैं number of moles of CHCl3 and number of moles of CH2Cl2. Okay, number of moles of CHCl3 given mass by molar mass. What is the given mass? 25.5. ठीक है. मोलर मास कितना हो जाएगा? क्लोरीन का होता है 35.5, है ना, और इधर हो गया आपका 13, तो 35.5, 5 5 5 15 हो गया, है ना, 15 हो गया. एंड देन यू विल हैव 15 and 90, 16 and 119 point something आना चाहिए. प्लीज कैलकुलेट दिस ना. 119.5 और समथिंग कुछ होगा जहाँ तक हमको लगता है. What is the molar mass for CHCl3? 119 ना, 119.5
119.5
है ना, grams, and यहाँ पे हो जाएगा grams per mole. So you will calculate this value and then number of moles of CHCl2, CH2Cl2, this will be again but by molar mass which will be equal to 40 grams divided by, अब यहाँ पे कितना हो जाएगा, Cl2 will be 35 35 70 70 1 71 71 और 71 और यहाँ पे कितना हो गया, 12 2 14 71 और 14 85, 85 grams per mole. ठीक है. So what will be the values, approximate values कितना हो जाएगा, 25 है, this is 119, तो लगभग ये 20/100, so this will be approximately 0.2 और 40 0.5 के नजदीक, 0. थोड़ा सा 5 से कम होगा, ये 0.2 होगा. कैलकुलेट करके बताइए कितना आ रहा है आंसर.
सर 0.47.
दूसरा का, सेकंड का ना.
यस सर.
ठीक होना चाहिए 0.47, but 0.5 से थोड़ा कम. ठीक है. मोल्स राइट, ग्राम्स एंड ग्राम्स विल कैंसिल आउट ईच अदर. इसमें बताइए 25.5 अपॉन 119.5, इसमें समवेयर अराउंड 0.2, थोड़ा ज्यादा होगा आई थिंक 0.2 से, या फिर 0.2 के बराबर होगा. फॉर द फर्स्ट वन इट इज 0.221. लेट अस सी अनदर आंसर्स. बाकियों के बताइए कितना आ रहा है. और नहीं, दोनों ही हो सकता है, आई डोंट नो द एग्जैक्ट थिंग. देखते हैं, वी विल कंपेयर द आंसर्स. ओके. अच्छा 0.213 आप कह रही हैं. ओके फाइन. एनीवन एल्स फॉर द फर्स्ट वन, CHCl3 में व्हाट इज द नंबर ऑफ मोल्स?
0.2 सर.
नहीं 0.2 नहीं, एटलीस्ट यू शुड हैव 2, कम से कम तो आपके पास ये होना चाहिए ना, 2 digits after the decimal place. मोहम्मद सैफ इज सेइंग 0.21, ठीक है 213 हम ले लेते हैं इसको. श्राव्या का आंसर 0.213 है. आई थिंक दिस इज करेक्ट. ओके, चलो. We have got the number of moles. Now we can calculate the mole fraction. Mole fraction of what? CHCl3. This will be equal to the number of moles of CHCl3 divided by number of moles of CHCl3 plus number of moles of CH2Cl2, which will be equal to 0.213 divided by 0.213 plus 0.47. ठीक है, इसको कैलकुलेट कर लेंगे. Then we'll calculate the number of the mole fraction of CH2Cl2. ये कितना हो जाएगा? 1 minus the mole fraction of CHCl3. ठीक है, चलिए कैलकुलेट द फर्स्ट वन, उसके बाद नेक्स्ट वन. 0.213. This will be divided by 1. This will be divided by 0.4 तो 6 7 1 8 0.683. इसको ऐसे किया कीजिए हमेशा 213 डिवाइड बाय 683 है ना. बोथ आर हैविंग 3 डिजिट्स आफ्टर डेसिमल प्लेस है ना, तो हटाई दीजिए, डिवीजन में आराम होगा. कितने के बराबर हो जाएगा ये? 2/6 1/3 0.3 के कुछ आना चाहिए नजदीक.
सर 0.31.
0.31. एनीवन एल्स? कितना आ रहा है? ओके, श्राव्य 0.311. ठीक है, 0.31 लेते चलते हैं. 0.31 ये कितना हो जाएगा? 1 माइनस 0.31. बाकियों का आ रहा है कि नहीं आ रहा है आंसर? हाँ, यस. रिदा, मैमूना.
Yes, sir.
अच्छा. श्रेदा, रूफिया, हाउ आर यू?
I'm fine, sir.
यू आर फाइन. यू आर लेट. कितने बजे आई आप?
Sir, I came at 6
यू केम एट 6.
or 6:05, around 6:05.
6:05 नहीं, 6:05 भी नहीं. 6:05 तक तो हम इंतजार कर रहे थे, व्हाइट बोर्ड नहीं खोला था हमने. आप जब आए थे तो व्हाइट बोर्ड खुल गया था.
Yes, it was.
व्हाइट, हाँ हाँ, तो वो 6-5 के बाद ही आए हैं आप.
Okay.
चलिए, क्या हो रहा था? सो रहे थे फिर क्या?
No, sir.
ओके. 1 माइनस 0.31. 0.69.
69.
ठीक है. ओके, नाउ वी हैव गॉट इट. P total will be equal to P naught A. P naught A नहीं लिखते हैं. P naught of CHCl3 into the mole fraction of CHCl3 plus the P naught of CH2Cl2 to the mole fraction of CH2Cl2. तो इसका कितना दिया हुआ है? आई थिंक जस्ट 200 ना, पहले वाले का 200 CHCl3 का 415. ठीक है, 200 CHCl3 is 0.31 plus P naught, P naught ही बोलते रहे. This will be 415 into the mole fraction of CH2Cl2 0.69, and all of this thing will be in mm of Hg. No, because the pure, it is given in the terms of mm of Hg. So please calculate this.
Sir, what is mm of Hg?
Huh?
So what is mm of Hg?
अब्दुल रहमान, आप हमारे साथ स्टेट्स ऑफ मैटर में थे 11th स्टैंडर्ड, या लेट आए थे आप?
No, sir.
अच्छा, आप नहीं थे हमारे साथ, लेकिन यू वर देयर इन 11th स्टैंडर्ड ना?
Yes, sir. At the end.
अच्छा, एट द एंड आप आए थे. mm of Hg is one of the units. Okay, it is one of the units of pressure. ठीक है, and 1 atm is equal to 760 mm of Hg. ठीक है, जैसे आपके पास टॉर होता है, बार होता है, एटीएम होता है ना, पास्कल होता है. ऑल ऑफ दीज आर व्हाट? यूनिट्स फॉर प्रेशर. सो mm of Hg is also unit of pressure. Okay, so please calculate this. I think that is correct, Shravel. I'm waiting for a few more answers. Please calculate and send the answer in chat. Correct. So all of you are getting 348.3. Okay, now, so we have got the answer for the first question. Okay, we have got the answer for the first question. So P total. What is the second question? Second question is to calculate mole fraction of each component in vapor phase. Just Ravya, can you tell me what is the value that you are getting after multiplying these two things? 62. Tell me, Shravya, 62. And for these two? 286.35. Okay. Okay. Calculate the mole fraction of each component in the vapor phase. Okay. So what you have here, we had a container in which we had CH2Cl3, sorry, CH2Cl2 and CHCl3. अब उसी में क्या किया हम लोगों ने? Similarly, you will have vapor phase maybe same things, blue and black atoms. Now they are saying that let us just focus on the vapor phase. So we'll just focus on the vapor phase. यहाँ पे you have gas which is CHCl3, CHCl2, and they are asking what is the amount of CHCl3 and what is the amount of CH2Cl2 in mole fraction. Now this question is important. You can't measure it, so you have to calculate it. Now, if you remember the Dalton's law of pressure. Sorry, इसको क्या करते हैं आप देखिए. According to Dalton's law of partial pressure, see what we will do. Generally we write mole fraction in the terms of chi, लेकिन earlier we have already used है ना solution in दो phase है आपको पता होना चाहिए. In this case you have two phase. You have a phase that is of solution, and then you have a phase which is of vapor phase, है ना, which is vapor phase. So vapor phase के लिए what we will use the term that is y. Solution के लिए क्या use करेंगे हम? Chi of A and chi of B. Vapor के लिए क्या use करेंगे? अगर उसी का vapor है ना, if you have solution and then its own vapor, so for that vapor we will use the mole fraction, and the term that we'll be using this y here, and y of CHCl3 and y of CH2Cl2. We know according to Dalton's law of partial pressure that mole fraction of a gas is equal to its partial pressure, let's say y1, which is equal to P1 upon P total. ठीक है, अब इसको लिखिए. I will tell you how. 11th class में पढ़ाया जा चुका है, but still I will tell you how. Right now what you will write, Dalton's law of partial pressure के मुताबिक y1 is equal to P1 upon P total. So y of CHCl3 will be equal to the partial pressure due to CHCl3 divided by the P total, whatever the total pressure is from this. And then we can write y of CH2Cl2 will be equal to, just 1 minus कर देते हैं यहाँ पे, CHCl3. Okay, so what is the pressure of CHCl3? You can go above and you can see that this is the pressure of CHCl3, है ना, which is 62 mm of Hg, 62 mm Hg डिवाइड बाय P टोटल जो हमें कैलकुलेट किया वेपर फेज के लिए वो कितना आया? P टोटल इज 348.35 which is equal to 348.35 mm Hg. Okay, so you will cancel this and then calculate and tell me what is the value here. ठीक है, mole fraction of CHCl3 which is in vapor phase, mole fraction of CHCl3 in vapor phase. Please tell me what is this, and after that I will explain this equation here. Okay, please write it down. Please write it down. Just wait a second. Huh? Calculate and tell me what is the value for Y of CHCl3. Yeah, got one answer. Okay, Shravya. Let us see what others have to say. So you're getting this as 0.17. So this will be equal to how much? 0.81. 0.83, sorry. Okay, can somebody please confirm these answers? Calculate and tell me.
Yes, sir. Same.
Same? Okay. Yes, yes. Yeah, obviously, that will be 0.83. 0.83 is ठीक है. ये तो 0.83 आएगा, इसमें कोई दो राय नहीं है. This will be 0.17. इसको कैलकुलेट करना था, राइट? इसको ठीक है. Now let us understand. इसको states of matter में same thing we have studied, but let us also try to understand here. ठीक है. Can I move? Yes or no? Rida, tell me. Rufia. Answer आया आप लोगों का? Rida and Rufia.
Yes, sir.
Okay, fine. Study. So what we said for gases, na, please don't write this thing. For gases, I said that mole fraction of A, it will be equal to the partial pressure of A divided by the P total. Abdurrahman, can you please turn the mic on? Abdurrahman, can you please turn the mic on? Okay, are you not here? अब सवाल देखिए ना क्या है. In vapor phase. Abdurrahman, can you see it? Yes or no? Please tell me. At least हम आप माइक नहीं ऑन कर पा रहे क्या हो रहा है? Listen here, guys. Listen here. Mole fraction of A, it is equal to pressure of A divided by P total. Now this is for gases, yes or no? All of this is for gases, yes or no? Please tell me. Dalton's law of है ना gases. अब देखिए P of A के लिए हम क्या लिख सकते हैं? For P of A I can write number of moles of A into RT divided by volume. Similarly, what I can write for P total, number of moles, that is total, into RT upon V. Is that right, yes or no? Please tell me. करेक्ट है? अरे PV is equal to nRT, है ना? Here we will have number of moles that is of only A, and this will be divided by total. So we'll just cancel these two things, and you will get what? Na upon n total. And what is this Na upon n total? This is nothing but the mole fraction of A, right? So if you have the partial pressure due to A divided by the total pressure, you will easily get the mole fraction of A. Is that clear? Yes or no? This is Dalton's law of partial pressure. Got it?
Yes.
Okay. Now, Abdur Rahman, can you please turn the mic on so I can explain you what you were asking? या फिर आपको समझ में आ गया? Why are we calculating mole fraction again? Yes, Abdur Rahman. अरे भाई आया नहीं आया, पता नहीं. Some of you guys have real difficulty in internet or what? Okay. Now, so we have done one question here. We have also done one question there. What else is remaining? Okay, so Rawls law is almost done, I think. Rawls law is almost done. Now we are moving to a different topic that is very important, which is ideal solutions. Okay. After Rawls law, we have to understand things about ideal solution. What is an ideal solution? Let me just see if we have completed everything. I think we have completed everything. No. There's one thing missing. Sorry, just ideal solution से पहले Rawls law as a special case for Henry's law. ठीक है? We'll see the similarity between Rawls law and Henry's law. एकदम दिमाग से निकल जाता है. ULTS Rawls law. As a special case of Henry's law. Okay, of Henry's law. Now, if you see Rawls law, this statement that we usually write now, P total is equal to P naught A chi A plus P naught B chi B. This is not exactly the Rawls law. Okay, ये Rawls law का application, that is right. It is related to Rawls law, but it is not exactly Rawls law. If you remember Rawls law says that partial pressure of a liquid in a solution, partial pressure of the vapor phase of a liquid in solution will be equal to its pure vapor pressure into the mole fraction. Similarly, Henry's law what states? It states that the pressure of a solution will be equal to Kh into chi B, the mole fraction. And here many things are similar. You are here also getting pressure, here also pressure, right? This chi B is what? This is mole fraction. This chi is also mole fraction. This is a constant. This is also a constant. Henry's constant. And this is also constant. Now, more importantly, if Kh is high, solubility is, tell me what is solubility, high or low? Tuesday को ही पढ़ाया.
Solubility is low.
Solubility is low. Very good. Solubility is low. Now listen here. If P naught A is high, that means the pure liquid, it is easily escaping out. Yes or no? The pure liquid is easily escaping out, making more and more vapors. If pressure is high, there will be more vapor. Correct है? Yes or no? Maimuna,
Yes.
Saif, Rida.
Yes, sir.
Yes. Okay. If there is more vapor, that means liquid particles is escaping out. Yes or no? Yes or no, guys?
Yes, sir.
If it is escaping out, it is not in the solution, not in solution. If it is not in the solution, that means if this is also high, then the solubility is low. Correct hai? Yes or no, please tell me. Is that right? Can all of you see this? Yes. अरे नहीं, मैमूना, रिदा. हाँ या ना, तो पुलिस में आप लोग इतना टाइम क्यों लगा देते हैं हाँ ना बोलने में? Otherwise you can say just wait sir. सोचने दीजिए सर थोड़ा सा. ठीक है? So both of these things you can say that almost it is same, but how is Rawls law a special case for Henry's law? Rawls law is a special case for Henry's law because instead of KH, what are we having? You are having P naught A. P naught A. Now the KH होने से क्या होगा? The KH is for, it is kind of generalized, but if you see P naught of A, then it is dependent on what the particular liquid is. So you will write Rawls law. Please write with me. Rawls law becomes a special case of Henry's law, in which KH becomes what? It becomes equal to the vapor pressure of pure component. So please write this down. Rawls law as special case of Henry's law. After this, we will discuss the most important topic of this lecture, that is ideal solution and non-ideal solution. Done, guys? Yes or no? Please tell me.
Yes.
Okay. Now, before even writing the topic ideal solution, non-ideal solution, let us understand this. Let us understand this. What is ideal and what is non-ideal? Now, ideal and non-ideal. Ideal and non-ideal. So you have, whenever you are making a solution, please don't write any of this. Okay, don't write this. Whenever you are mixing, you have two components. Let us say A. There is component A, and now what we are dealing with, we will be looking in the terms of and from the perspective of intermolecular forces of attraction. So let us say in the let us say in the solvent A, we have the intermolecular force of attraction like this A. And in B, these are not bonds, these are intermolecular force of attraction. Between two molecules, we have this kind of force of attraction. There is AB, okay? AA and AB. Now, when we mix it, then what is going to happen? A will be interacting with B, and A will be interacting with B, and B will be interacting with A. So we will be having intermolecular force of attraction like this AB and AB. First of all, tell me, do you understand this whole thing? Yes or no? Please tell me. This is after what we are doing here, we are mixing it here. Yes, Abdul Rahman, Memuna, Saif, Rida, Shravi, and
Yes, sir.
Rufia.
Yes, sir.
No problem till here? Okay, fine. Now, okay. Now, in this case, you can easily see, you can see that there is IMF, right? Intermolecular force of attraction. Attraction here, there is attraction here, and there is attraction in this case also. Okay. Now, see, if the attraction in this side is equal to, that means attraction before is equal to attraction after. Okay, let us say there can be only two cases. Attraction before is equal to attraction after. Yeah, it is unequal. Well, let us see what is the case if the attraction before is equal to attraction after. Attraction before is equal to attraction after. First thing we will look at, which is easy to understand, is the volume. Okay, don't write any of this. Volume. अच्छा, अब ये बताइए आप. In this case, we will have, let us say, V1 volume. यहाँ पे आपके पास V2 volume. ठीक है? V1 volume and V2 volume. So, if the attraction is same even after the mixing, even after mixing the attraction is same, then we can say that यहाँ पे भी आपकी ए बी के बीच में जो डिस्टेंस होगा दैट विल बी इक्वल टू द डिस्टेंस बिटवीन ए एंड बी बी। करेक्ट है ये बात? if the attraction is same, that means they will be attracted in the same magnitude. If they are attracted in the same magnitude, that means the distance will be neither more than a or more than bb, nor it will be less than a or less than bb, because it is the attraction is equal. Yes or no? Is that clear? जो distance होगा a और b के बीच में that will be equal. नहीं आया, किसी को नहीं आया? अरे हाँ या ना बताइए।
Sir, can you explain again?
एक्सप्लेन अगेन। ठीक है, अट्रैक्शन इज इक्वल, ये मान के चल रहे हैं हम लोग। ओके, दिस इज एन अजम्पशन। ओके, आगे बढ़े।
Okay, sir.
Sir, attraction of AA and BB is equal.
हाँ ये अट्रैक्शन ऑफ ए बी बी तो इक्वल है ही। हम बोल रहे अट्रैक्शन बिफोर द मिक्सिंग, यानी कि यहाँ पे जो अट्रैक्शन है दिस होल थिंग ये इक्वल रहेगा ही रहेगा। इट इज ऑल्सो इक्वल टू हियर अट्रैक्शन आफ्टर। ये बात समझ में आई सबको?
So how is it equal after?
तो नहीं है इक्वल कर दें?
No, sir. My question is, how is it equal? Like over here in the first case, it has the same alphabet, so that's why it is equal. But over here,
नहीं वो बात हम नहीं बोल रहे थे। आई एम सेइंग वो भी केस आएगा जब इक्वल नहीं है। ओके रिदा,
sir, I did not understand this.
आई एम सेइंग दैट कैन दे बी इक्वल, या कभी भी इक्वल नहीं होगा? टेल मी दैट। Can the intermolecular force of attraction of the components and in the solution, can they be equal? Yes, Rida?
I don't.
अच्छा, you are saying that you don't know. देखिए, so let us say they will not be equal. Yes, Rida?
Yes, sir.
They will not be equal then, ना? If you don't, देखिए इसका मतलब ये है they can be also equal, they cannot be also equal. It will depend on what are the solute we are taking and what are the components we are taking. Correct है?
Yes, sir.
तो वही तो हम बोल रहे हैं, अगर कुछ ऐसा कंपोनेंट होगा जिसमें इक्वल हो तो उसका केस बता रहे हैं अभी हम। फिर आई विल टेल व्हेन इट इज नॉट इक्वल। अब समझ में आया?
Yes, sir.
ठीक है, assumption लेके चल रहे हैं ना। वी आर सेइंग दैट लेट अस टेक नाउ दिस ग्रुप ऑफ, अभी जो भी एग्जांपल्स वगैरह नहीं है, एग्जांपल्स वगैरह लेटर बाद में आएंगे। ठीक है, नाउ वी आर सीइंग द अट्रैक्शन बिफोर इज इक्वल टू अट्रैक्शन आफ्टर। दैट मींस अट्रैक्शन इन द कंपोनेंट्स वेदर इट इज AA और BB is equal to the attraction in the solution between A and B. Is that clear? Yes or no? Please tell me. Riddha, Shravya, attraction वाला point clear है कि नहीं है?
Yes, sir.
What about others? Maimuna, Saif, Shravya, Sayyida, Rufia. What about you guys?
Yes, sir.
जबरदस्ती नहीं करना, ठीक है? नहीं आ रहा तो बता दीजिएगा, ठीक है? At any point. Okay. If the attraction is equal, then AA के बीच में जो डिस्टेंस होगा, है ना, the distance between the two molecules of A will be equal to the distance between the two molecules of BB, है ना, and it will be also equal to the distance between the two molecules of A and B in the solution. Is that right? Correct है?
Yes, sir.
Okay, that means if AA is taking V1 volume and BB is taking V2 volume, then the solution will be taking V1 plus V2 volume, है ना? ये बताइए, ये समझ में आया कि नहीं आया? एकदम एग्जांपल लेके चले क्या हम, आप लोग को अमाउंट्स बता के। AA, let us say that it is taking 1 centimeter cube. BB is taking 1 centimeter cube. आपको सोल्यूशन में क्या मिलेगा? You will get one AB and another AB. AB में भी हम क्या बोल रहे हैं? AB distance is also equal to AA and BB. So this will be also 1 centimeter cube. This will be also 1 centimeter cube. तो जो आपको इसका वॉल्यूम नजर आ रहा है, that is equal to how much? V1 plus V2. Correct है?
Yes.
What about others, huh?
The volume are equal.
हाँ, बिफोर मिक्सिंग एंड आफ्टर मिक्सिंग, ये ध्यान रखिए। आप यहाँ पे प्लीज मत कंपेयर कीजिए, रदा, ठीक है, डोंट कंपेयर V1 एंड V2, आई एम सेइंग बिफोर मिक्सिंग क्या वॉल्यूम है आपके पास, बिफोर मिक्सिंग यू हैव वन वॉल्यूम दैट इज V1, अनदर वॉल्यूम दैट इज V2, ठीक है। इट इज जब आप ऐड करें तभी आपके पास वॉल्यूम क्या आ रहा है, V1 प्लस V2 वॉल्यूम आ रहा है, यानी कि वॉल्यूम में कोई चेंज नहीं आया है, ठीक है, वॉल्यूम में कोई चेंज नहीं आया है। नाउ लिसन, अब यहाँ पे आप देखिए एक केस हम लेके चलते हैं, ठीक है। लिसन, हियर यू आर हैविंग AA BB, उसमें आपको क्या मिल रहा है देन, AB एंड AB। Okay, now I am saying that attraction before mixing, it is less than the attraction after mixing. Okay, now we are taking one case in which you have attraction that is greater after mixing, ठीक है, after mixing the attraction is greater। अब ये बताइए जो AB के बीच में डिस्टेंस है that will be high or low if I compare it with the components। If the attraction is higher, then the distance will be what, high or low?
Things will be more.
Lower, right? The distance will be lower. If the distance is lower, that means the volume. If the distance is lower, that means the A and B molecules, they will be sticking together, na? They will be taking less volume. Yes or no? Correct hai? You understood this point? Yes or no? Are, tell me what happened.
Sir.
Yes, Rida?
No, sir.
No?
At this point, B
Answer me.
high or low,
Answer.
this distance.
I am saying the distance between A and B will be lower if the
How will
attraction is
it
high.
be lower?
Attraction is higher.
Yes, sir. Yes.
है ना, अट्रैक्शन ज्यादा होगा तो डिस्टेंस विल बी लोअर। अगर डिस्टेंस लोअर है तो वॉल्यूम क्या हो जाएगा, व्हाट विल बी द वॉल्यूम, लोअर या हायर?
High.
है, if the distance is less, volume will be,
The volume will be high.
सोच के थोड़ा बोलिए। और डिस्टेंस का ही तो क्यूब होता है वॉल्यूम, डिस्टेंस ही कम है तो फिर क्यूब तो कम ही होगा ना। यस रिता? नहीं, what about others? Tell me, Maimuna, Saif, Shravya, Saida, Rukia, what do you think? Volume will be lower या higher? वॉल्यूम कम होगा या ज्यादा होगा? If there is more attraction, the attraction is higher, then the volume will be lower or greater? Lower or higher? Yes, Maimuna, tell me. What do you think?
I think it will be higher.
If attraction is higher, volume will also be higher, Maimuna?
Oh, if attraction is higher. Okay, then I
attraction
think
is
it will be
higher.
low.
Attraction is higher ना, ये साइन तो दिखता होगा, I think. Okay. Rida, still you are not convinced the volume will be lower? Yes, Rida, are you there?
Yes, sir.
You are still not convinced?
Sir, actually, I'm confused in between this. So,
Between which things? Tell me.
this one only, the same, the one which you are explaining.
अरे नहीं, इस यहाँ पे तो हम बहुत सारे स्टेप है ना, एक स्टेप है आपका यहाँ तक। I am assuming that we are taking a case in which the attraction after mixing is higher than the attraction before mixing. यहाँ तक क्लियर है या ये भी नहीं?
Yes, sir.
यहाँ तक क्लियर है?
Yes, sir.
यहाँ तक क्लियर है। अगर अट्रैक्शन ज्यादा है तो क्या होगा, डिस्टेंस दोनों मॉलिक्यूल्स के बीच में कम होंगे। यहाँ तक क्लियर है? नहीं, ये भी नहीं क्लियर है।
Sir, if distance is more than,
नहीं, डिस्टेंस ज्यादा नहीं है भाई, अट्रैक्शन जब ज्यादा है तो डिस्टेंस में क्या होगा ये बताइए ना आप। इफ अट्रैक्शन इज
sir,
हायर,
actually your voice is breaking in between. I'm not able to hear you
अच्छा
clearly.
ठीक है ठीक है ठीक, तो मैं अब ये दिखते हैं, इज माय वॉइस ब्रेकिंग फॉर एवरीवन?
No, sir.
नो ना, अच्छा रिदा आप देख लीजिए फिर कुछ हो रहा होगा आपकी तरफ से, है ना। इफ यू कैन एडजस्ट समवेयर लाइक, पता नहीं जो भी कर सकते हो आप। इज इट क्लियर नाउ
Yes,
रिदा?
sir. Yes, sir. Now it is clear.
नाउ इट इज क्लियर, ठीक है। जब अट्रैक्शन इज हायर द डिस्टेंस विल बी लोअर, योर लोअर या हायर, ये बताइए आप। दो लोगों के बीच
It
में
will be
अट्रैक्शन बहुत,
lower.
इट विल बी लोअर, ठीक है। अब वॉल्यूम बताइए आप।
Like that will
Well,
also be lower.
यही तो कह रहे थे हम इतनी देर से, और क्या कह रहे थे
Yes.
ना, आप उल्टा बोल रहे थे ना, आप वॉल्यूम ज्यादा बोल दे रहे थे, राइट?
Yes. sir.
ठीक है, चलिए कोई बात नहीं। ओके सो वॉल्यूम इज लोअर, है ना। तो वही यहाँ पे, दैट इज द ओनली थिंग दैट आई एम सेइंग, दैट देयर कैन बी सम सॉल्यूशन इन व्हिच इफ यू मिक्स 10 ml of one and 20 ml of the other, you will be getting what? You will be getting 30 ml of the solution, ठीक है। if your attraction before mixing is equal to attraction after mixing, but if there will be some solution in which you mix 10 ml of A, 20 ml of B, and you are only getting 28 ml of the solution, in which what is happening, if you are getting 28 ml, that means the volume is lower, that means attraction after the mixing became more stronger. Attraction after the mixing, they became more stronger, okay. So this can be the case. Now listen very carefully. Now listen very carefully. Listen very carefully. This is the case that I am taking in which attraction is higher after mixing. If the attraction is higher after mixing, now you all will tell me, molecules will escape easily, yes or no? ये बताइए आप लोग। आपने यहाँ पे लिक्विड रख दिया, right? Here you have liquid and the attraction between A and B is very strong. अब ये बताइए, what they will be easily getting out, they will be easily escaping out, evaporating out, or there will be difficulty? Tell me. Molecules will escape easily, yes or no? Will, हाँ बोलिए बोलिए। श्राव्या, सैफ, सईदा, रुफिया, आप लोग है ही नहीं क्या क्लास में? कैन यू गाइस आंसर? अब्दुल रहमान, टेल मी, the molecules will escape easily, yes or no? Yes, Saf, tell me. I can't hear you, Saf.
Sir,
क्या
I
हो
think
गया?
it's no.
No, सही है। Saf, what do you think?
After mixing.
After mixing, I'm saying, what will happen? The molecules will escape easily, yes or no?
Maybe yes.
ये आप लोग को क्या हो गया? बिल्कुल हाँ।
Sir,
अरे जब
actually,
हाँ, actually
now
what?
this way. So this one, like I said no. So
I can't hear you,
the
Rita.
answer. So now can you hear me?
हाँ, I can hear you. बताइए। I can
So
hear
my
you.
answer is no because right now you said the attraction is more, then the distance will be less. So that's why I said no.
हाँ हाँ, आपने तो सही कहा, उसमें हम कहाँ कुछ कह रहे हैं। I'm saying Saf is saying maybe yes. I want to see why it is yes or why you are saying no. Maimuna, tell me, if attraction after mixing is high, then in the solution, the molecules will be escaping easily, evaporating easily, yes or no? अगर attraction high है तो?
No.
No ना?
Yeah.
I think. Okay, fine. What about others? Shravya, what do you think? They will escape easily, yes or no? I think Shravya is not here. Say the Rufia, tell me. Abdurrahman, okay. Yes, Sayyida Rufia.
Yes.
I have been asking question. आपको नहीं आ रही क्या आवाज Sayyida Rufia? Yes, Sayyida.
Yes, sir.
आपको आवाज नहीं आ रही क्या मेरी? Yes sir आप बोली जा रही है बस।
No, I mean the molecules will escape easily. Yes.
अच्छा, you are saying the molecules will escape easily.
Oh.
Attraction high है ना? Attraction high है Rufia. Keep answering me. Keep your mic on, Rufia. हाँ, द अट्रैक्शन इज हायर। अब दो
Hmm.
लोगों के बीच में अट्रैक्शन हायर है तो उसको कोई आसानी से छुड़ा के ले जा सकता है? दे विल एस्केप इजीली, यू आर सेइंग, इफ द अट्रैक्शन इज हायर। व्हाट इज हैपनिंग रूफिया? ध्यान नहीं दे रही हैं आप लोग? नाउ सी द क्वेश्चन दैट आई एम आस्किंग, इट इज नो ब्रेनर। नो ब्रेनर मींस इवन इफ यू रीड इट प्रॉपर्ली you should answer it, and if you are not answering that means आपके दिमाग की गलती नहीं है, आप पढ़ ही नहीं रहे क्या बोला जा रहा है, या फिर आप सुन ही नहीं रहे क्या बोला जा रहा है। and even if you are even if you are listening something, you are thinking something else right now. Am I right? Yes or no? Tell me. Yes, Rida, Shravya, Maimuna.
Sir, I've answered.
I've देख लिया हमने। हम ये पूछ रहे हैं, दिस इज नॉट अ ब्रेनर क्वेश्चन ना, इसमें दिमाग लगाने वाली बात नहीं है ना। If attraction will be higher, they will not escape easily. सैयदा रुफिया, समझ में आया कि नहीं आया ये बताइए आप, कि कहीं और दिमाग चल रहा है आपका? I mean, दिमाग आपका कहीं और चल रहा है, इसका ये मतलब नहीं कि आप क्लास में नहीं, क्लास में ही चल रहा होगा आपका, लेकिन किसी और टॉपिक में होगा, या फिर कुछ और समझ रही होंगी, जो हम बोल रहे हैं वो नहीं समझ रही होंगी आप। ये सैयदा रुफिया, प्लीज टेल मी फास्ट।
I did not understand.
What did you not understand? Tell me.
When the attraction is higher.
Attraction higher है, ठीक है। Escape का मतलब पता है आपको? Escape, evaporate. You understand these terms ना, सैयदा
Yes.
रुफिया?
Yes.
अब आप खुद सोचिए, in the molecules there is more attraction, so if you have to take the molecules out of the solution, that means you have to break the attraction, yes or no?
Yes.
If you have to break the attraction, then how is it easy to escape? नहीं आया अभी भी?
No, sir.
हाँ,
No.
आपको क्यों लगता है आसानी? अच्छा, दो लोग के बीच में बहुत अच्छा अट्रैक्शन है, बहुत कस के पकड़े एक दूसरे को, और दो लोग ऐसे लूज लूज खड़े हैं, किनको इस मतलब बाहर निकालना आसान होगा? जो लूज लूज खड़े हैं, जो बिल्कुल एकदम एक दूसरे से चिपक के खड़े हैं?
जुलूस
जिसमें अट्रैक्शन कम है वो ना, जिसमें अट्रैक्शन ज्यादा है
जी
वो आसानी से निकल जाएंगे। जिसमें अट्रैक्शन ज्यादा है वो आसानी से निकल जाएंगे क्या? नहीं ना?
यस
है जिसमें अट्रैक्शन ओ
नो
वेट अ सेकंड,
नो
सॉरी,
जिसमें अट्रैक्शन कम है वो निकलेगा,
और जिसमें अट्रैक्शन ज्यादा है
वो नहीं निकलेगा।
तो if attraction is higher after the mixing, the molecules will escape easily, yes or no?
नो
Will they escape easily?
नो
अब
नो
आया?
यस आई गॉट इट।
लाइक आपको समझ में आ रहा है आप क्या मतलब, लाइक व्हाट यू वर सेइंग अर्लियर कितना गलत था?
यस
क्यों कह रहे थे आप भाई? ओके, लिसन हियर ऑल ऑफ यू, attraction is higher, molecules will escape easily. No, they will not escape easily. If they will not escape easily, there will be less vapor. Correct है ना? If they are not escaping easily, there will be less vapor, yes na?
यस
Yes, sir.
Vapor pressure will be low. Correct, yes or no? Please tell me.
Yes, sir.
If there will be less vapor, that means you have less gaseous molecules. If you have less gaseous molecules, the vapor pressure will also be less. That means the pressure applied by gaseous molecules, it will be also less. Is that clear? Yes or no? All of these points?
Yes.
Yes, sir.
Okay. अब यहीं से बात आती है, देखिए अब यहाँ से ना, this is again, this is way more important. Now what we have, how we have seen, यहाँ से आप start कीजिए अगर, intermolecular force of attraction, which is it measurable? No, you can't measure intermolecular force of attraction in a simple laboratory, right? Intermolecular force of attraction, and we have come from a very microscopic, atomic or molecular point of view, and we have elaborated and we have come up with what? We have come up till vapor pressure, which is what? Measurable. Okay, which is measurable. In if you see vapor pressure, you can easily measure by using barometer or manometer. Now, how to compare this? How to compare this? See, an ideal solution and non-ideal solution में क्या फर्क होता है? We have this equation which is P total, which is equal to P naught A chi A Please listen very carefully. Don't write anything. Okay. P naught B chi B. Is that clear? Yes or no? We have this one equation. Now, please listen very carefully. Please listen very carefully. P naught A, we will get this from data booklet. Yes or no? P naught B, we will get this from data. Yes or no? Correct? Hai?
Yes.
Yes, sir.
Now, if you are preparing a solution, then you can take 0.7 A ka mole fraction. You can take the other mole fraction 0.3. So both of these things are data. Hai na? P naught A, P naught B, chi A, chi B, all of these things are data. Yes or no? Please tell me.
Yes, sir.
Then you have blocked this thing. You have gas as atom here. You have blue gas atoms. And then what do? You bring up a manometer or a barometer and then you measure the total pressure. Now, if you see these terms, all of these are data and what? Yahan pe to you will have to just calculate it. So this is the calculation part. This is calculated. Okay, this is calculated. You take P naught A of one thing, chi A of the other thing, plus P naught B of other thing, P naught and chi B of other thing. Then you measure the P total. Okay, so you will get a P total from this, which will be calculated. Okay, which will be calculated, and then you will get a experimental P total that you will measure. समझ में आ रही है बात? Yes or no? Please tell me. There is something which is calculated. There is something which is experimental, which is measured. Can all of you see that? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Right? Okay. Now here only you will see difference. Here only you will see difference. You will see that the P total which is experimental, it will be either equal to the P calculated, ठीक है, जो कि आपको यहाँ से मिलेगा, और P experimental will not be equal to P calculated. If P experimental is equal to P calculated, then we say that this is ideal solution. And if it is not, then we say that it is non-ideal solution. Is that clear? Yes or no? Please tell me.
Yes.
Yes.
Okay. Now, the reason in the from the molecular point of view is what? It is intermolecular forces of attraction, right? Intermolecular forces of attraction. If they are equal before mixing and after mixing, then it is ideal. Lekin, we say this in terms of the Raoult's law and in terms of pressure. Why? Because we can measure these things. We can measure these things. That is why all the definition of ideal and non-ideal that you will be looking in any of the books, it will be given in terms of Raoult's law. Initially, it is very difficult for the students to understand why it is Raoult's law. Raoult's law kahan se aa gaya? Ideal, non-ideal. So see, this is the reason why Raoult's law, because we can measure it. But the base or the fundamental molecular level reason is again intermolecular forces of attraction. Okay, so you will write the first thing, that is ideal solution. Heading डाल लीजिएगा, ideal and non-ideal. Ideal and non-ideal solution. Okay, now the first one will be ideal solution. So what is ideal solution? So you will write with me. An ideal solution, an ideal solution is defined as the solution which obeys Raoult's law, over entire range of concentration. Over entire range of concentration. Okay, over entire range of concentration. In an ideal solution, the components, sorry, wait a second. In ideal solution, the attraction between the molecules of each component is equal to the attraction after mixing. Okay, it is equal to attraction after mixing. Now, some of the characteristic, what will be the characteristic? Number one, characteristic of ideal solution. Number one, volume change is zero. Okay, volume change is zero. What does it mean? It means that volume before mixing is equal to volume after mixing. Okay, so you can also write like this. You are mixing A plus B, and it is giving you AB, and here V1, V2, here we have V solution. We said that if it is obeying the Rawls law, the V solution will be equal to V1 plus V2. Okay, this is before mixing. Okay, आपका before mixing, and this is our after mixing. Okay, so volume changes zero. Second point is, second point, please write with me. Heat change is zero. अब इसको समझ लेते थोड़ा. चलिए, please write till here, then we'll understand heat change. All of you understood till volume change, yes or no? यहाँ तक explain किया हुआ है. Yes, Rida, Maimuna, Shravya, Seda, Rufia.
Yes, sir.
Okay, fine. Rida, Saif, आप लोगों को समझ में आ रहा है
Yes,
ना?
sir.
अब्दुल रहमान. Okay, good. Heat change पढ़ते हैं. यहाँ तक लिखिए आप लोग. Please raise your hand after you are done. Raise your hand when you are done. सेदा रुफिया, आप भूखी वगैरह हैं क्या? आपने खाया हुआ या नहीं है क्या? ये सेदा रुफिया.
No, sir.
हाँ, तो खा पी के बैठा कीजिए, ठीक है? पता नहीं कहाँ ध्यान था आपका, लेकिन होता है, नॉट अ प्रॉब्लम, है ना? ऐसा नहीं कि पहली बार हुआ है किसी एक स्टूडेंट के साथ, ये सब होता रहता है. ऑब्वियसली चीजें नहीं दिखती हैं, है ना? सो इट्स ओके, चिल रहने का, ज्यादा टेंशन नहीं. हीट चेंजेस जीरो, ये पढ़ते हैं हम लोग अब, है ना? सो अब्दुल रहमान इज डन. वेटिंग फॉर मैमुना, रिदा, श्राव्या एंड सेदा रुफिया. Waiting for Rida and Rufia and Saif. Please raise your hand now if you are done. Rida, are you there? Let me चल रहा है क्या इनका फिर से? Okay.
Yes.
All of you.
Yes,
Okay.
please.
All of you, please listen. All of you, please listen. You have AA attraction. Just listen, don't write, and BB. Giving you AB and AB. ठीक है? AB and AB. Now, in order to dissolve AA and BB, what we have to do? We have to break these intermolecular force of attraction, and we will be forming these two. Correct? Yes or no? Please tell me. We have to break AA and BB, and we have to form AB and AB. Yes or no? Please tell me. Oh God, yes or no? Please tell me. Yes, no. What about others? Rufia, Rida, Saif. नाम लेना पड़ता है. Please say yes, sir, if you have understood.
Yes, sir.
Rufia को नहीं आया समझ में, रिदा को नहीं आया समझ में.
No, sir, I understood.
Yes,
तो
sir.
why you are not? हाँ, तो
Yes, sir.
बोलिए ना फिर. Okay, thank you very much. Thank you very much. So we have to break and we have to form. Now, if मतलब we have taken the case where the intermolecular force of attraction is same before mixing and after mixing, before mixing and after mixing. That means the amount of energy that will be required in order to break will be equal to the amount of energy that will be released after formation. That means whatever
Sorry
in
to jump in between. Could you please repeat it as the again voice is breaking?
हम इसमें क्या कर सकते हैं? I am saying हम लिख के बोल देते हैं. Okay, रिदा आप जो हम लिख रहे हैं वो देख लीजिएगा. I am saying that if the intermolecular force of attraction are same, the intermolecular force of attraction are same, that is why the amount of energy that is required to break the bonds, है ना, that will be equal to the amount of energy that is released when the bonds are formed. Bonds मतलब intermolecular force of attraction. इनको break करने के लिए जो भी energy लगेगी, that will be formed, that will be released when these are formed. Yes or no? Please tell me. Rida,
Yes,
did you
sir.
hear it?
Yes.
Did you understand it?
Yes,
आया
sir.
समझ में सबको?
Yes.
Mamuna, Rufia,
Yes.
okay, fine. That
Yes,
means
sir.
heat change का मतलब क्या? जो आप दे रहे हैं वो आपको वापस मिल जा रहा है. अगर जो आप दे रहे हो आपको वापस मिल जा रहा है, that means the enthalpy is zero. Enthalpy is delta H. It is equal to zero. Delta H is equal to zero. And why is this? We'll write this when there is no change. When there is no change in the magnitude when there is no change in the magnitude of attraction, the magnitude of attraction between components before and after mixing, before and after mixing, then delta H of mixing will be also equal to zero. The enthalpy change will be zero. So इसको ऐसे लिख लेते हैं. Delta H mixing will be zero लिख लेते हैं. बात आई समझ में सबको? Yes or no? Please tell me. And if I want to summarize this thing about ideal solution, we can summarize it like this. Sentences, we will write this down. Ideal solution number 1 point. Obeys Rawls' law. Second point. Attraction before is equal to attraction after. Attraction of what? Attraction between the components. Okay, simple छोटे words में लिख दिया हमने. Third, volume change zero. That means delta V is equal to zero. Fourth point, heat change zero. That means enthalpy of mixing is zero. यहाँ पे भी V mix लिख दीजिए, ऐसे रहता है generally. ठीक है? So these are the 4 points that you have to understand, that you have to remember. Understand तो छोड़ दीजिए, याद रखिएगा कम से कम. Okay, please remember this, है ना? Remember this, and it will help you in understanding also. Okay, it will help you in understanding also. Please write this down. Raise your hand when you're done. Rida is done, Shravya is done, waiting for Abdul Rahman, Maimuna, Saif, and Syed. अच्छा सॉरी, एक काम कीजिए, साथ साथ इसके एग्जांपल्स पे लिख लीजिए आपको. ठीक है? एग्जांपल्स में फॉर एग्जांपल बेंजीन and toluene. No, so both of these have just the difference of one carbon atom. Secondly, for example, hexane and heptane. Hexane and heptane means normal hexane, straight chain wala, not any other isomer, and normal heptane. Okay, so again, not much difference, only of one carbon. Thirdly, chloroethane. The chloroethane is a liquid, and bromoethane. Again, not much difference, just one level down, you will have bromo. So all of these are the cases in which the intermolecular force of attraction. Now there is not even much difference between benzene and toluene. So intermolecular force of attraction में क्या ही difference होगा, नहीं? Similarly, hexane and heptane and chloroethane, bromoethane. दोनों में ही बहुत ज़्यादा का difference है नहीं. Then how the physical property, that is attraction between the molecules, how will they differ, right? So more or less, the attraction between two benzene molecules and two toluene molecules is equal to the attraction between one benzene and one toluene. इन दोनों के बीच में जो attraction होगा individual के attraction के equal होगा. Okay, that is why these are the examples for ideal solution. Okay, now non-ideal solution तो और जल्दी हो जाएगा because you have already done it. That means explanation तो हो चुका है उसका. Second is non-ideal solution. Non-ideal solution. Now non-ideal solution is what? The solutions which do not obey a solution which do not obey क्या? Rawls law. At me over the entire range of concentration are called non-ideal okay. कितना scroll करना अब्दुल रहमान? Let me know if I have to scroll more.
Sir, can you repeat again?
Let me know if I have to scroll more.
No, sir.
More. नहीं अब्दुल रहमान से पूछ रहे हैं. Till here, Abdul Rahman? Please write it fast. बाकी लोग भी लिख लीजिए नॉन आइडियल सॉल्यूशन तक. Then again, similar same type of characteristics will be there. है ना? We will also write different things. As you have written for ideal solution, you will write for non-ideal solution. Abdul Rahman, let me know when you're done, okay? Abdul Rahman, please let me know when you're done. Okay. Chalo. So after this, you will write. If they do not obey the Rawls law, so what is Rawls law? Rawls law says that PA will be equal to P naught A chi A. So we'll say that this is not equal to P naught A chi A, and PB is equal to P, and that is why what will happen? P total will not be equal to. Wait a second, guys. Okay. पूरा इंटरनेट में भी a bit चल जाएगा. You all can hear me right now? ठीक है. P total is not equal to plus sorry. हाँ ठीक ठीक ठीक. So how about now, Rida? Tell me.
Well, it is continuously breaking. I'm not able to.
What about others?
My
So
audio,
your voice is breaking.
my voice audio. There are texted.
Rida, आपको पता चल गया. What about others? Shravya, Sedar,
Yes, sir. Your
breaking,
voice is breaking in between.
breaking in
Yeah,
between.
but sir.
How about now? Still breaking?
No, sir.
Okay. अब Rida, आपके लिए still breaking? Okay. So non-ideal solution. We just have to write. ठीक है? Let me know if you have any doubt. Intermolecular force of attraction in solution will not be as that of individual component. Individual component. Number one, characteristics में you can write. Wait a second. Characteristics. Number one will be volume change is non-zero. Now, what does it mean? It means delta V of mixing is not equal to 0. Second point, heat change is non-zero. That means delta H of mixing is not equal to 0. Okay. So obviously there will be two cases of non-ideal solution. There will be a case in which the intermolecular force of attraction will be higher. There will be a case in which the intermolecular force of attraction will be lower than the individual components before mixing. So we will study those two types of non-ideal solution in the next lecture. Now there are two announcements. Sunday you will have test. Sunday you all will have test. Topic. There will be always whenever you are learning concentration terms, whenever you are learning the chapter solution, जब तक टेस्ट होगा solution chapter का एक ना एक सवाल आपका concentration terms से रहेगा ही रहेगा. ठीक है? So you'll have some question from concentration terms for sure. Okay. Now, instead of other than concentration terms, you will be asked about solubility. In solubility, you will have first of all the solubility, then the solubility of solid in liquid. Then you will have solubility of gas in liquid. Okay, and after that, in gas and liquid, there is also a good application or factor which is pressure, and which comes under the topic of Henry's law. Okay, Henry's law will be there, and then I will ask you about vapor pressure. Simple vapor pressure. ठीक है, Rawls law नहीं रहेगा. Rawls law will not be there because I will be asking about Rawls law, ideal solution, non-ideal solution एक साथ. ठीक है, एक पैकेज में I will be asking about these things. तो vapor pressure तक रहेगा आपका. Okay, I have got some messages. Oh, okay,
So will
okay,
this
Shravan. हाँ बताइए.
will this be conducted in class or will be uploaded
No, no,
in
no,
the
no, no.
portal?
In the portal only. It will be on the portal. Okay. The
Okay, sir.
Sunday test will be on your student portal. Okay. Now there is one more announcement, which is tomorrow on Friday, na? Till Friday at 4 p.m. Okay, Ruda, you can wait for a while. Okay, after the class. At 4 p.m. you will have class on concentration terms. Okay, now you tell me who are the students who want class on concentration terms. Please raise your hand. I think Rida, आपको तो लेना होगा because आपका नहीं हुआ है.
Yes.
And similarly Rufia, आपका भी नहीं हुआ है ना? What about others? बाकी सबने किया है ना? मेमुना, अब्दुल-रहमान, सैफ, शराबिया,
Yes.
है ना?
Yes,
बाकी
sir.
सबका हुआ है. ठीक है. Rida and Rufia will be there for tomorrow's class 4 p.m. and timing. This is KSA timing. ठीक है?
Sir, I won't be
Yes, sir.
available on Friday.
Why?
Sir, because I'm going outside.
You don't go outside.
No, sir, I'm going to Umrah.
अच्छा, you are going. अच्छा, इसी Friday को.
Yes, sir.
अच्छा, what you will be doing at 4 p.m.
We are going at 3
So you will be
afternoon.
traveling
Yes,
in the
sir.
afternoon. Will be traveling. ठीक है. ठीक है. तो you will watch this lecture then. ठीक है ना? Recording अब आपको देखना पड़ेगा. Okay?
Okay, sir.
Recording देखिएगा. जो डाउट्स होंगे नोट डाउन कीजिएगा एंड उसके बाद हमको बताइए. किसी एक दिन आपको हम डाउट्स फिर क्लियर कर देंगे अलग से क्लास लेके. ठीक है?
Okay, sir.
ओके, ठीक है. ओके, सो रिदा आप रुके एंड ऑल ऑफ यू अदर्स कैन लीव. है ना? थैंक यू वेरी मच. टाटा, बाय बाय, टेक केयर, अल्लाह हाफिज, अस्सलाम वालेकुम.
Thank
Thank
you.
you, sir.
थैंक
Thank
यू,
you.
बाय बाय. थैंक यू, थैंक यू, थैंक यू. हाँ रिदा, आप बताइए क्या बोल रही थी आप?